Natali and Camacho Cruz, and we will be presenting our project, Plant-Based Fuel Cell for Electricity, Making Lives Better by Rebuilding Sustainable Communities. Our first topic in today's agenda will be a brief introduction, followed by our two main methodologies, which were food production and affordable energy, activities, entrepreneurial action we take on the project, our timeline for our research basis of the project, future work, and a brief conclusion.
So we are part of a team called Enactus, and Enactus is a global organization focused in believing and investing in students who take entrepreneurial action for others to create a better world. This group organization has more than 1,700 teams all around the world and more than 17,000 students on those teams. They take pride on the Sustainable Development Goals, which are 17, and each team must choose at least one of those to create a project around it. These 17 goals were established in 2015 by world leaders and is expected to be achieved by 2030. Our project is called Leader Engineers, and it's an educational project for high school students who are taught aspects of applied science, sustainable agriculture, and entrepreneurship. So this project started because looking into Puerto Rico's social, economic, and environmental situation, we focused on two main targets. The first of those were that 85% of our food consumption comes from other countries outside Puerto Rico. And since Hurricane Maria over 2 years ago, 80% of our farms were devastated by it. So that caused a rise in our nutritional insecurity. On the other hand, our Department of Education established back in 2015 that 0.87% was our scholar desertion index, and it has risen up to 15%, and it's expected to continue to rise.
Additionally to our project, we also focus on educating, guiding, and empowering future generations to both impact their communities and themselves. Another important thing we do on our project is that we have two solutions in one hydroponic system: food production and affordable energy. Why food production? Because the typical hydroponic system is composed of PVC tubes. Our system is composed of a panel of PVC instead, which is an innovative and efficient way of producing crops. How? Because by eliminating the tubes, we don't have to have a water pumping system, electrical water pumping system, and therefore we can double the number of plants being sown. Additionally, to maintain a healthy crop, we use a pro-mix, which is a mix of pebbles and moss, which this mix will help the system absorb more water and serve as a natural water pumping system. And why affordable energy? When as you can see in the image, when the process of photosynthesis occurs, when the sunlight, when the plant absorbs the sunlight, that energy goes to the roots of the plant, and therefore the microbes in the plant decomposes those organic substances of the solar energy and produces positive and negative charge atoms, which are then absorbed by our 12-volt battery and then used to charge small mobile devices. Another important aspect of our project is that we are using compost made from our own university to maximize organic or maximize microbial production and enhance electron release. And by using this, we are retrieving waste from landfills and redirecting them up to 15% to organic waste and 14% of them to compost material. Also, this residue has the potential of being used as organic fertilizer. As I said before, our goal is to charge a small mobile device like a phone and to an LED light. With our previous test runs we have had in our university, we have a very high promise of achieving this goal in our near future.
So our project is providing a door frame for changing the common use of an electrical energy, and it creates a way for those students to generate money that will help their community. First, we focus on education and system development with these students, then on sustainable agriculture, where we generate our own harvest and electricity, and then we generate our sales implementation, where we propose that these students should invest 10% of their gains on the project, and the rest will go directly to their community. We have an entrepreneurial approach for these projects, so we're seeking to enhance student perspectives by combining science and leadership activities inside and outside school. With that passion, our leader engineers were able to create a partnership with groups inside and outside school in their community, so they can sell their harvest.
Additionally, not only the students were able to create alliances, but the teachers as well, because they made an alliance with a 10th grade marketing group in the school, and in doing so, the students improved their abilities in public speaking. At the beginning, we selected the students to help them sell their crops to the community, but through communication with them, we determined that the best possible course is to give them the freedom to sell their own crops, because only they know what is best for their community. Also, by doing this, they are being exposed to the marketing and economic environment, business, and they have the potential to identify potential clients and future improvements for the project. Additionally, we are currently in the phase of experimentation and data collection for the research basis of our project. You have already done the identification of the problem and research. Interpretation will be done by our mentors, professors, and teachers in the school, and the publication will be available to the school and the university, so the students can complete their education. And our future work for the project will be implementing 4 prototypes in selected school by the end of this year to have a more impact on society. Analyze the results for better identifying areas of opportunity of our project, and to determine and extend the plans to include our system into 20 households to have a more direct impact economically and socially to the community.
So it is important to note that our main goal is to comply with these 17 goals. And we selected a few for this project, starting with quality education by complementing classroom experiences involving those students in dynamic environments, promoting good health, well-being, and less hunger by promoting a good mental health and good nutrition, and gender equality and inequality reduction by changing the way they live by accepting different paths after high school. Affordable and clean energy as well by using beneficial tools that help the environment using STEM techniques, and promoting pro-climate action like on land and life below water by limiting environmental impact, and lastly, no poverty, sustainable cities by constructing a safe and open environment for those who wish to achieve change. Together we're creating a path for social justice, environmental, sustainability, and accessible solutions with these students. Thank you. Any questions?
I have a question. How easy was to arrive to that model of panels instead of like tubes? You mentioned that you changed the tubes for panels. That was your first choice?
Yeah, originally we made one together with our construction team of our system. We selected a traditional approach to this system, but through cost and other analysis we made with our mentors, and we determined that the best possible course of action is using a panel, because like I said, it doubles the number of plants being sown, and the cost is less to have. And to communication with our construction team was the best possible course of action.
So you mentioned different teams. So how many people are in this group of students then?
Almost 30 from mechanical engineering, civil engineering, chemical engineering, environmental, industrial, and electrical.
So it's a whole team of students working on this.
Multidisciplinary team of students.
Natali, on the sustainable goals, which one of those sustainable goals are you working with the team?
Quality education mostly by preparing presentations and activities with the students. And
An important aspect also is that through this education, this type of dynamic education we're providing them, they are being more energized by the things they are learning in the classroom, then applying them on a practical basis. It's like a boost of energy, if you will, to further have knowledge.
and they're able to see what will they do after high school.
So I can understand, you said that the plant, once it has photosynthesis, creates like negatively and positively charged electrons, right? And in the soil, and that's how you collect,
Yeah.
what are you using to collect them? Or how
Yeah.
is it being collected?
Through on the cables we have in the system has cables, then that the energy being produced in the soil, as you can see in the image, is being transferred to the energy to the battery, and therefore the battery has the energy to charge the mobile device between other. It's still on a experimental basis, but it's been promising what the results have been.
I have a question. In the design change from PVC tubes to these trays, I wanted to know if the way you guys are doing this experimentation, if these processes are being exposed to solar energy.
Well, right now, we are, I don't know if it answered your question, but we initially wanted to have a prototype of this system that also uses solar energy, but the cost is
I'm gonna rephrase the question. Are they indoors or outdoors?
outdoors.
Outdoors.
Yeah, they're outdoors in the Polytechnic University.
Okay.
Any more questions?
Congratulations.